We're going to look at a couple more things in this lesson. We're going to look at box plots, and we're going to really formalize what's going on with outliers. So that's kind of the idea of what we'll be looking at in this lesson. So an outlier, we had said before, informally was any data value that was significantly different than the majority of the data, significantly farther away or something like that. As a general rule of thumb, we say an outlier is any data value that's more than 1.5 times your interquartile range beyond your quartiles. We would say that that is an outlier if it is 1.5 times your interquartile range above your third quartile or upper quartile, or 1.5 times your interquartile range below, subtracted from your first quartile. So any data value that's smaller than that would be an outlier, or any data value that's larger than that would be an outlier. Now, we can go ahead and draw a box plot. A box plot really works with our 5-number summary. We have our max and our min, our quartiles and our median. All those are available by looking at our box plot. You want to start off by drawing a numerical scale appropriate for your data. So if your data is between like 5 and 10, you'd do a scale from 5 up to 10. If your data is like from 100 all the way up to 3,000, you'd have to do a scale that way. Now, on your scale, you want to find where your first quartile is and where your second or third quartile is. So mark those and then draw a box going in between them, basically a rectangle. Then you want to go ahead and find your median on your scale and mark that, and that line should be somewhere in between the two ends of your rectangle that you just drew. You then want to go ahead on each end of your quartile, each end of the box, go from your, so like your upper quartile, your third quartile, you draw a line to the right, or going up depending upon your scale, to your most extreme data value that's not an outlier. And then you go to your first quartile, your lower quartile, and draw a line going to the left to your first, or to the most extreme data value that's not an outlier. Then all your outliers that are not, if you have outliers, sometimes you won't have outliers, but if you do, then you're going to mark those values either as an asterisk or a dot. So let's go ahead and take a look at those Hollywood movies again. Now, here is a box plot of the movie data. So here's our median. Here's our upper quartile, our lower quartile. Here's the most extreme case that's not an outlier. And then here we have little circles for all of our outliers. We had said before that these up here were outliers, but by the formal definition, also these in here were outliers. So we have our median, we have our first and third quartile, which is 50% of your data, is all within the box. 25% of your data lies on each side of the box. And once again, your whiskers, these lines extend and tell you your last data value that's not an outlier. If you don't have outliers, they'll extend to your maximum and they'll extend to your minimum. So then the rest of these are all your outliers. So here we have a situation where we have our Nathan's famous hot dog eating contest. And how many hot dogs can you eat in 10 minutes? Now, for the normal person, it would not be this many. But for some of these that are professional eaters or just like eating a lot, they were included in this famous hot dog eating contest. So based on the box plot here on the right, pause the video and estimate your mean, or you mean your median, your range, your interquartile range. So as we look here, our median is right here, and I would say that's about 54 as I go straight to the left. My interquartile range would have to go from here down to here. Well, this is 50 in the bottom. As I come over here, that's about 62. So 62 minus 50 would be an interquartile range of 12. My range should be the difference between the max and the min. My min is 45. My max as I come over looking at my scale, I would say is about 68. So 68 minus 45 gives me my range. So we had looked at all the black stuff before, and we just basically added another way to visualize our one quantitative variables, and that's with a box plot. So what happens when you have one quantitative and one categorical? So consider this situation here. So go ahead and read through this. In other words, we're trying to see if our tea or coffee makes a difference. So that's our explanatory variable. Makes a difference in what? Well, that would be our response variable, which is how our immune system responds. So, because this is randomized and it's an experiment, we can actually say one thing causes the other. So we can show causality with this. So here's the data. We have our box plots of the tea. We have our box plot for the coffee. You'll notice coffee does have an outlier. And then we have what we're measuring over here on the side of our response variable. You can see that for the tea, it is significantly more than the coffee. Not all of them, but on average. So, what can we do? When we're looking at these, all we have to really do is look at our means. And we could figure out the mean of each one. And in this case, the mean of our tea is 34.82. The mean of our coffee is 17.7. Now, one of the things we did with our proportions was look at the difference in our proportions. We can do the same thing for the difference in our means for our quantitative data. So for this case, we take the mean of our tea, 34.82, minus the mean of the coffee, the 17.7, and we get a difference in the means of 17.12. So when we're dealing with one of each type of variable, we can go ahead and break it into groups. We could do the difference in our means. To visualize it, we can do side-by-side box plots. We could really do side-by-side histograms or box plots too, but for the most part, we just looked at the box plots for this one.